Okay, working up to 13, 14, and 15. Anytime we're expanding binomials, remember you have two choices on how you're going to find your coefficients. Something like the fifth power, I would probably go to Pascal's triangle. So you're going to have to make your own. Remember, one's on the outsides, add the two numbers above, 1 plus 2 to make the next, 2 plus 1, 3, one's on the outside, 1, 1, 4, 6, 4, and then 1, 1, 5, 10, 10, 5, 1. Now I know I can stop there because I'm doing a fifth degree, and this would be row 5. Okay, so I know the first term is going to have a coefficient of 1. X is to the biggest power, and there are no y's because I already have my total exponent of 5. Plus, next coefficient 5, decrease the power on the x, increase the power on the y. So now 4y is going to be to the first. Plus, next term, coefficient 10. X is decreasing, so it's cubed. Y is increasing, so it's now 4y squared. Back to Pascal. Coefficient, there we are, coefficient 10. X is squared. 4y is to the third. Plus, next coefficient 5. X to the first. 4y to the fourth. And then last term, coefficient is back to 1. We're out of x's, and 4y is to the fifth. So this is the non-simplified version. Now we need to go back and simplify. Okay, first term's all set, 1x to the fifth. Next one, we have a 5 that needs to be multiplied with the 4 to the first. So that creates a 20. X to the fourth y is our second term. Plus, third term, 10, now multiplied with 4 squared. 4 squared is 16. 16 times 10 is 160. X to the third, y squared. Plus, next one, 10 times 4 cubed. 4 cubed is 64. 64 times 10 is 640. X squared, y to the third. Next one is 4 to the fourth, which would be 64 times 4. I think that's 256. But I'm going to check to make sure. 4 to the fourth. Yep. And then times the 5 that was in front. So 1,280 after we get that 5 in. So 1,280, xy to the fourth. And then last term was 4y to the fifth. So I need 4 to the fifth for my coefficient, which is 1,024. Y to the fifth. And so there's our expanded binomial. If you go back and check, every term should have a total degree of 5, and there should be a total of 6 terms. 1, 2, 3, 4, 5, 6. Okay? Now the next one, first 5 terms of 2x minus y to the 12th. There's no way I want to keep going with my triangle until I get to the 12th row. So I'm just going to use the combinations that we've talked about to get the coefficients. Now for the first couple, you shouldn't have to do a whole lot of work. The first coefficient is always 1, and then the first term to the biggest power, 2x to the 12th. Next one, remember this diagonal right there always represents the power that you're using. Since we're using a 12th degree, then my coefficient becomes 12. The power on the x's decrease, the power on the y increases to the first. There's my second term. Plus, now I'm stuck. I don't know what the next number in the 12th row is going to be. So I'm going to skip it for a second. Go ahead and do my powers on the x and the y. So 2x to the 10th, negative y is squared, but that helps me out with the combination. Remember, 12 is always going to go to the top because it's our total, and either of those numbers can head to the bottom. I'm going to pick the 2. Plus, next one, 2x is to the 9th, negative y is cubed. Coefficient is going to come from a 12 and either a 9 or a 3. Let's see, so we have 1, 2, 3, 4 terms. I need one more. 2x is to the 8th. Negative y is to the 4th. Coefficient out front, 12 to the 4. Okay, so now we go back and simplify. First one, 2 to the 12th. And yes, these numbers are going to be huge because of these big powers. So 4,096 plus, x to the 12th. Plus, next one is going to be 12 times 2 to the 11th. And, I forgot about negative, so I'm going to change that to a minus instead of a plus. So minus 24,576 x to the 11th y. Okay, next term's going to go back positive because it's a negative with an even power. Combinations, 12, math to the left, and then remember we're doing a combination, so we choose NCR 2, but then there's also a 2 to the 10th contributing to the coefficient. So that is 67,584. X to the 10th y squared. Okay. Next one, combination of 12 and 3. We're going to go back to minus. So 12, math to the left, number 3, 3 times 2 to the 9th. Coefficient is 112,640. X to the 9th, y to the 3rd. And then last one, 12 C4 times 2 to the 8th. Final coefficient for the first 5 terms anyway is plus 126,720 x to the 8th, y to the 4th. Now you know this is going to keep going because there's going to be a total of 13 terms, but there's the first 5, just like I asked. 1, 2, 3, 4, 5. Okay, next problem, last one I'll do on this section. Find the 8th term of an expansion. Don't use 8 as an exponent. We're going to subtract 1. That creates the second exponent in the problem. So that's going to be the exponent on our y's. So I'm going to go ahead and start building from the back. 4y to the 7th power. Now we know we're going to have a total of 20 for the exponent. I've already used up 7. So 3x is going to be the 13th. That helps me again with my combination. 20 goes on top. Either of those goes on bottom. And then we're going to multiply all that out. Again, this is going to be huge because we've got big numbers, we've got a combination, we've got powers. Why is my calculator not working? 20, and we're paused. I can sing a little song for you. Are we working now? There we go. 20, math, left, 3, 7, times 3 to the 13th, times 4 to the 7th. There we go, scientific notation, it's big. So coefficient 2.0, let's go 502 times 10 to the 15th, x to the 13th, y to the 7th. And there's anything you'll need to do with expanding binomials, either using Pascal's triangle or using the combinations.
For 2 days.